Hi, my name is Bill Sun, and I'm going to be discussing a web application that I developed called Malaria, which provides a fast and reliable means of diagnosing malaria from thin blood smear images. So as you all probably know, malaria is a serious and sometimes life-threatening mosquito-borne disease of global importance. Currently, the analysis of thin blood smear images, in which a drop of a patient's blood is spread onto a glass slide, stained by some regions, and examined by a trained laboratorian, is commonly considered the gold standard for laboratory confirmation of malaria. However, the results of such testing depend heavily on the amount of time and the amount of experience of the laboratorian, both of which can be severely lacking in the tropical and subtropical regions where malaria is most prevalent. The web application that I developed is completely automated and is thus capable of diagnosing the degree of infection by malaria parasites in a fraction of the amount of time that would take a clinician to do so manually, allowing clinicians to devote more of their time to other important tasks. So this is the web app that I made using the Flask web framework library in Python, as well as a bit of CSS and JavaScript. The user first goes to the home page, which provides some relevant information and statistics about malaria. If interested, the user is also able to look at some in-depth discussions about my model development, deep learning, and related literature. To upload an image, the user first takes a short survey and is then able to upload their blood smear images. Now I'm going to upload a few example images for testing. This web app centers on two deep learning models, an object detection model and a classification model, which were both trained and evaluated in Python using the Keras library. Given a thin blood smear image, the object detection algorithm predicts bounding box coordinates for three of the major components of blood: white blood cells, red blood cells, and platelets. Then the detected red blood cells go through a convolutional neural network, which functions as a classification algorithm and determines whether or not an individual red blood cell is infected by the malaria parasite. Finally, the user is provided with a data summary indicating the relative levels of infection, as well as the individual zip files to download for the infected red blood cells, uninfected red blood cells, white blood cells, and platelets. As you can see in these particular examples on blood smear images that I found online, both the object detection and the classification model were fairly accurate at detecting out the locations of the cells, as well as classifying them. Hopefully the speed and reliability of this web app will have a positive impact on patients in malaria endemic regions. Thank you.